My name is Tasweeb Yusuf, and in this video I will present my project Multi-Class News Topic Classification on the AG News dataset using TF IDF, Word2Vec, and multimodal machine learning. The goal of this project is to build a complete NLP pipeline that takes the raw news articles and automatically predicts one of the four topics: world, sports, business, or science and technology. I will walk through my notebook step by step, from data loading and exploration through pre-processing and feature extraction to model training, evaluation, and finally a Streamlit web app. The dataset, I start the notebook by importing the main Python libraries, pandas and numpy for data handling, and matplotlib um, and seaborn for plots, NLTK and gensim for NLP, sticklearn for machine learning, and TF IDF and TensorFlow for keras and neural networks. Next, I load AG News. AG News training file train.csv using pandas. The dataset contains a numeric label, a news title, a description. I map the numeric labels to clear names: world, sports, business, and science and technology here, and combine the title and description into a single text column. I display the first few rows to confirm the structure and check for the missing values or obvious data issues. This section sets up everything I need for the rest of the pipeline. The data is loaded, labeled, and sorted, stored in the convenient format. The next part of the notebook is exploratory data analysis. First, I plot the class distribution using a bar chart of the label name column. This shows how many examples belong to each topic. For AG News, the classes are roughly balanced like this, which is ideal because none of the topics dominates training. Then I look at text length statistics. I create a text length column that counts the number of tokens in each article and plot a histogram. This helps me understand whether the dataset is mostly short headlines or longer descriptions and informs decisions about model complexity. I also create word clouds here for each class. Before generating them, I remove English stop words so that the most prominent words in each cloud are topic specified. For example, the sport word cloud highlight the team names, and sport terms, while the business cloud emphasize finance-related vocabulary. These visualization give a qualitative feel for how the topics differ and confirm that labels make sense. After understanding the data, I move on to pre-processing. I define a clean text function that lower cases the text, removes URLs, digits, and punctuations, and normalizes white spaces. I apply this function to the text column to create a new clean text column. Next, I tokenize the clean text using NLTK. NLTK removing stop words so remaining tokens carry more semantic meanings. The resulting tokens column is a list of tokens for each article and serves as the foundation for Word2Vec. With the pre-processing done, I built two types of features: TF IDF, and later we will build a Word2Vec document embeddings. So for the TF IDF, here, I used scikit-learn's TF IDF vectorizer with the chosen vocabulary size and an n-gram range, including unigrams and bigrams. I fit this vectorizer on the training text and transform the training validation and test sets into sparse matrices. These TF IDF vectors capture how important each word or phrase is to each article, like this. Then I create Word2Vec document embeddings. I train a Word2Vec model on the tokens sequences. This model learns a dense vector for each word. To represent an entire article, I take the average of its word vectors, giving one fixed length vector per document. These dense vectors are later fed into the neural network. To visualize these spaces, I apply PCA, principal component analysis. Here, principal component analysis to both the TF IDF and Word2Vec representations. Reducing them to dimensions, I plot the documents in 2D colored by topic. While there is some overlap, the plots generally show the articles from different classes clustered in different regions, confirming that the features are really meaningful. The core of the notebook is modeling. I split the dataset into training, validation, and test sets using stratified sampling so that each split keeps the class distribution. I then trained three models, here. I trained three models, multinomial naive Bayes using the TF IDF features. This model assumes that the words occur independently given the class. It is simple and fast. After training, I evaluate it on the validation and test, etc., etc. Logistic regression, also on the where is it? Logistic regression here, over there. Yeah, this was the multinomial, and then this is the logistic regressions. This is also on the TF IDF features. This linear classifier often performs very well for the high dimensional text data. Then I used feed forward neural network using the Word2Vec document vectors. To interpret the results, I built a small table summarizing accuracy here. I built a small table summarizing accuracy and macro F1 scores for all three models. I also put confusion matrices for at least the best model. These matrices show where the model makes systematic mistakes, for example, confusing business with word, but really confusing sports with science and technology. Based on these matrices and visualization, I select the best model, which in my case is typically logistic regression, and with TF IDF features, and I save both the trained model and the TF IDF vectorizer to the disk using Pickle. The final technical part of the notebook is to focuses on the Streamlit web application. Here. In app streamlit.py, I import Streamlit and Pickle and then load the saved TF-ID vectorizer and the best model model Pickle, like here. Maybe I can see, no. But in my GitHub, you can see I have uploaded both of these files as well. And the app shows the predicted topic and probability for each of the four classes, turning the entire pipeline into the interactive tool. Like I can show my file. Here is my app. Okay, this is my app, how it looks like. And if I paste news paragraph into it and I click classify, it tells me how much are the class probabilities. It is like 0.198% or 19.8% for business, 38.5% science and technology, and 32.6% it's related to sports, and almost like 9%, 9.2% it is related to word. So this is predicted topic. The main topic is science and technology, or because it has the maximum probability. So this is how the app works. To finish the video, I briefly discussed limitations and future work. The system is trained only on the AG news and limited to 4 topics. So it may not generalize well to other domains or languages. The TF IDF and averaged Word2Vec features also ignore word order and deeper context, which can lead to misclassification on subtle or ambiguous articles. Future extensions could include transformer-based models such as BERT or more advanced hyperparameter tuning and additional datasets. In conclusion, this project demonstrated a full end-to-end NLP workflow, loading and exploring data, pre-processing text, extracting TF-IDF and Word2Vec features, training and comparing 3 models, interpreting results with metrics and confusion matrices, and deploying the best model in a Streamlit app. It shows how classical machine learning techniques combined with careful engineering can achieve strong performance on real-world news topic classifications. Thank you so much.